be differentiating this function. So this function is actually a square function, so it can be actually written like that. So sinus of x squared, like that. Cool. So to differentiate the square function or any function to the power, we know that it's known. It's known that if you have a function power, so to differentiate it, this one gonna be the power gonna come down. You differentiate the argument that is in the function, because the square function we have the argument inside, so the same with any function to the power. So the argument inside, we differentiate it, multiply that function to that power minus 1. So that's a formula to differentiate any function that has the power. So let's come back to our function. So if we differentiate it, our function, so it's going to be equal, so the 2 going to come down. So you're going to differentiate the function, the argument inside, come like that, and then that function, power 2 minus 1, right? So let's go further. So you keep differentiating. So the 2, let's rewrite it nicely. So that will be sinus square, right? So let's go one more time. So the 2 is there. So you differentiate that function now. So the argument gonna be x squared, right? So to differentiate any trig function, so you first differentiate the argument, that is x squared, and the differentiation of sinus is actually cos, so it's gonna be cos x squared multiply with that sinus x squared, right? So let's go further. So we're gonna be having 2. So now we differentiate x squared. We know x squared, if we differentiate it, it's gonna be what? It's gonna be 2x, right? Multiply cos x squared multiply sinus x squared, right? So here it's gonna be 4x cos x squared multiply sinus x squared, right? This is a differentiation of y, right? But we also know from the trig identities, it's known from the trig identities that sinus 2a example is equal to 2 sinus a cos a, right? When you see your differentiation of that function, you notice that we can actually identify the trig identities inside. So what I'm trying to say, to prove is, you see that 2 multiply with that cos square x with sinus x square, that here you can see it's gonna be like that. We're gonna be having 2x 2 cos x squared sinus x squared, right? So this one here, this expression actually represents the trig identities in your trig modules. So this one can be written like that. So you're gonna be having 2x, that you're gonna be replacing that by your trig identities. So it's gonna be sinus 2x squared. So the response is gonna be that. So that's a final answer. So hope you enjoyed the video. Hope you guys have understood what have been discussed. Please subscribe and don't forget to see the PDF or photo attached to the video. Thank you so much.